Now that we can destroy our hazards, we should reward our player with points. Let's count and display a score where every asteroid hazard destroyed gives our player 10 points. We will start by creating a display for the score before we create a score value to feed it with. First, using the Create menu in the Hierarchy view, select GUI text. This creates a new game object with a GUI text component attached. Rename this game object Score Text. We can now see GUI text being displayed in the center of our game area. The text property on the GUI text component drives what is being displayed. The rest of the component describes how this text is displayed and where this text is displayed on screen. We will not go into all of the details of the GUI text component. For more information on GUI text, see the details linked below. In later assignments, we will create additional GUI text objects to hold different information. With the default GUI text in the text property on all of them, the game view at edit time could become a little confusing. Change the text property to Score Text. We can see Score Text is now being displayed in the game view. We will be changing this value at runtime. Changing this label now will help us identify which display is which while editing. Our score text is currently displaying in the middle of our screen. Let's move it so it displays in the upper left of the game screen. Before we change any settings, it's important to understand that GUI text is drawn on a layer above our game, not in the game world. We won't see it in our scene view. Moreover, it is important to understand that the GUI text uses something called viewport space rather than screen space. The difference, very briefly, is that screen space is defined in pixels. This is the number of pixels wide and high that we set in our player settings. Viewport space is defined simply as a single width and height value, with 0, 0 in the lower left and 1, 1 in the upper right. With viewport space in mind, set the transform position on the display text from 0.5, 0.5 on the X and Y, in other words, the middle of the screen, to 0, 1, which is the upper left. The text seems wedged up against the upper left corner. It would be good to give it some pad or space around it to separate it from the edges of the game screen. Because of the viewport space, it is awkward trying to set such a small value of space using the transform component. The solution to this is to use pixel offset. Pixel offset is, not too surprisingly, using pixels. So we can set our primary location with the transform component, the upper left corner, and then perfect it with pixel offset. Change pixel offset to 10 and -10. This will give us a 10 pixel pad around our score text, separating it from the edge of the screen. Next, we need to feed score text a score value. Select Game Controller and open the Game Controller script for editing. The first thing we need is a public GUI text variable called score text to hold a reference to our GUI text component. The next thing we need is a public int variable called score to hold our current score. We use int because we will never count a partial point. Score will always be a whole number. Our game controller will keep track of our score, increment it when we destroy hazards, and feed that value to our score text. To update our score, we need to write a new function. Write void update score. And the code within this function is scoreText.text equals score colon space plus score. This function will set the text property on the score text component to the string score : plus whatever our current score value is held by our score variable. When written like this, Unity automatically converts the int value of score to a string of text characters, so it works with our text property. This feeds our score value to our GUI text component. We next need to update our score in two different places: when we first start the game, and when a hazard is destroyed. When we start the game, the first thing we need to do is set our score to 0. Then we want to call updateScore to set the score text to this starting value. Now, how can we tell from inside Game Controller when a hazard has been destroyed by the player? Well, we can't. But we can expose a public function to the other game objects in our game, like the hazards themselves, and when they are destroyed, the hazards can inform Game Controller to add to the score, and the Game Controller can use this information as a signal to update the score text. Let's create a public function for our hazards. Write public void add score with the parameter int new score value. First, we write code to update our score value with score plus equals new score value. And then we call the function updateScore to update our score text to display the new current score. We now need to call addScore from our game when a hazard is destroyed. Save this script and switch back to Unity. Let's look at our asteroid hazards. We want our instances of this prefab to call addScore on Game Controller when they are destroyed by the player. The player destroys our hazards through the DestroyByContact script. So open DestroyByContact for editing. First, let's give our hazards a value with public int score value. Now, how do we call a function on another component on a different game object? We could try to access this by writing GameController.addScore and then send the new score value with the argument score value. Save this script and return to Unity. Well, we seem to have an error. We can see the most recent error in the footer. Let's open the console and look at this error more closely. The error seems to be on the script we have just edited. Not surprisingly, the DestroyByContact script. This error says, an object reference is required to access non-static member GameController.addScoreInt. Why is this? This is because we are addressing the class directly, not a specific instance of our class. If we look at our GameController object, we can see that there is a GameController script attached. This is an instance of this script, or class. This is very much like all of the asteroid hazards or laser bolts that we have instantiated in our scene. Each one is an instance. Even though we have one and only one GameController script in our game, there is nothing technically stopping us from having several. If we created a new game object, say a cube, there is nothing stopping us from having another instance of GameController on it. Now we have two instances of our GameController script. When our hazard is destroyed, it needs to know which one to call addScore on. This is very much like valet parking. We can't simply say, "Please, can you bring our car?" We must have a reference to a specific car, usually through a numbered ticket, so the valet knows which one to bring. Let's delete our example cube. Even though we have only one instance, we still need a reference to it. That valet won't bring our car without a ticket, even if it's the only one on the lot. Reopen DestroyByContact for editing. Let's write a variable to hold our reference to our instance of GameController. Write public GameController, GameController. Note the two different capitalizations. The first GameController with a capital G is the class name or type. The second GameController with the lowercase g is the name of our variable. Now, if we copy and paste the name of our variable into the offending line of code, we change the line from addressing the class directly to using the reference to our instance that we have held in our variable. Save this script and return to Unity. And the error is gone. Let's switch to the game view. Select the asteroid prefab. We can now see the GameController type reference on the Destroy by Contact component. We need to associate our instance of GameController with this variable. So let's drag our GameController object onto the slot to make the reference. Okay, that doesn't work. Let's try to use the asset picker. Nope. This is not working. Why? This comes back to the nature of instances. Instances are copies of objects within a scene. Now, if we think about the nature of prefabs, prefabs are templates of game objects that can be instantiated in any scene in our game. It doesn't make sense that a template that can be added to any scene in our game can hold a reference to an instance in just one scene. Now, once we have instantiated our hazards into the scene, and we have an instance of our hazard, these instances can hold a reference to our instance of the GameController. So we have to find our references to the GameController after the game has started. Each new hazard will have to find a new reference to GameController when they are instantiated. Open Destroy by Contact for editing. Every hazard has an instance of this script, and every hazard will have to find their own reference to the GameController component on the GameController game object. Let's modify this script to do just that. In Start, we first need to find the game object that holds our GameController script. Let's call this reference the GameController object. We will set this reference by using GameObject findWithTag, and the tag we will look for is GameController. This will find the first game object in the scene that we have tagged as GameController, and we have only one. Remember, we tagged our GameController object with GameController when we created it. Next, if we have successfully found the GameController object, and we check this by testing the reference to the GameController object. So, if the GameController object is not null, where null means nothing or empty, essentially no reference, then we will set our GameController reference to the GameController component on the GameController object. We do this by searching the GameController object and getting the component on it with getComponent, searching for the type of GameController. Note this syntax, where GameController is in angle brackets, followed by parentheses. Technically, this is all the code we need. We are, however, going to write an insurance policy. If, after all this work, our GameController reference is the same as null, we will use debug.log to put cannot find GameController script into the console. Note that we are using single quotes around GameController, so the entire message is one string of text. This is an insurance policy. With hope, this line of code will never get called. If, however, something goes wrong, and we accidentally break something, and our game stops working or behaves badly, with messages like these in our console, we will have a place to start. Save this script and return to Unity. let's set up our asteroid hazard. Select the asteroid prefab game object and set the score value to 10. Below score value is the reference to game controller. We can't set this in the inspector. If we cannot set this in the inspector, let's not see it in the inspector. Open Destroy by Contact for editing. Change Public to Private on the game controller reference. Save this script and return to Unity. Now we have no access to this property in the inspector or from any other script. It is private. Let's set up our game controller. Select Game Controller. Take note of Score. Unlike the game controller reference on the asteroid prefab, we can set score in the inspector. We just don't want to. Score is handled perfectly well in the script. This property is set by the script on the first frame of the game, so let's set this one to private as well. Open the game controller for editing. Change Score from Public to Private. Save this script and return to Unity. We no longer see nor have access to Score. Let's set our reference to our score display. With Game Controller selected, drag the Score Text game object onto the Score Text property on the Game Controller component. Save the scene and enter play mode. And now we score 10 points for each asteroid we destroy, and the score is displayed in the upper left. Fantastic! Next, in the penultimate assignment, we will learn how to break out of our infinite loop and end the game.